I'll talk with you tomorrow, everybody, about what to expect on the exam, and I will be able to nail it down more in terms of what types of word problems you would expect to see and where you would expect to see them and how many there would be. But in the meantime, yesterday we went through setting five up. The shared task kind of problem, which I gave you an out at the end, which says you take the product of the two numbers divided by the sum of the two numbers, and that will give you the time it takes both people to do the job. It's a very valuable thing to remember. We looked at, I wouldn't say that this is a certain type of problem, like you're not going to see the same problem, but it's a type of problem where you have two numbers and you're told the relationship between those numbers. That's a classic kind of question. The problem involving speed, distance, and time for two things. It's a very important type of problem for you to know how to solve. I'm going to compare that to example 5, which is also a problem involving the motion of two things, but this is a very specific one where you're traveling upstream and then downstream. And the last one was a shared cost type of question that you definitely need to know how to do. Do me a favor, please. Take a minute and look over your work, and I'll be right with you, and we will go over some questions. Okay, and by the way, my focus here is on setting up the problems, but that being said, if there are any of those 5 problems we set up yesterday that you would like me to solve, let me know. Okay. Totally planned. Does anybody have any questions you would like me to go over? Go ahead, Sasha. Okay. Yeah. One of the things that is piled on top of this, it's a word problem, which is inherently difficult. It's probably going to end up being a quadratic result. I don't know. And then to pile onto all of this, it's like they're trying to keep all the information a secret from the student here. It's all buried in sentences. Some cows, I don't care where they're from. I really don't. Cows took 4 days longer to travel 70 kilometers. Okay. So what we have here is a comparison of the two situations. And I'm not even going to put descriptors of them. I'm going to have trip A and trip B, because I think you can read too much into the names of the places. It's just saying that you took the herd to Ford Lake from, I don't want to try to pronounce that word because I would mispronounce it. But the bottom line is there's part of the trip that took 4 days longer. And that trip, speed, distance, time, is 70 kilometers. Okay? And remember when we do these speed, distance, time problems that we always fill in one of the columns with numbers given in the question. Okay. It took 4 days longer than it took them to travel 60 kilometers. Blah, blah, blah. I don't care that it was beyond Ford Lake. It was the second part of the trip. They have the first part, which is going to Ford Lake, 70 kilometers. The second part, which is after Ford Lake, 60 kilometers. The second thing that I've asked everybody or said to everybody that you should fill in is put an X on the thing that you're trying to find. So we have a lot of sifting to go through. They averaged 5 kilometers less per hour less. That doesn't matter. What was their average speed? Okay, what was their speed for the part beyond Ford Lake? This is what we're trying to find. Now, we have to continue filling in that column. We can't just put X with the other part, but somewhere in all of this word salad is information telling us what we would do with the x to get this speed. And it's the averaged 5 kilometers per hour less before. So trip A is before, trip B is after. That means that this speed is x minus 4. And I'll tell you what, this question gives me a headache, trying to sort through it all. Yeah. Is it 5? Thank you. Yes, the 4 is the days. Thank you, Sasha. Whew. I mean, that's a lot of work just pulling that information out, and we're not even close to being done here because we still have to complete the third column. We have to then create a formula or equation. Then we have to solve the equation. Remember that your time is distance divided by speed. That's the key. And I think I can go out on a limb here. I think the problems that you will see in this course that are like this will always be ones where you're given the distance and you're asked to find a speed. So your distance column will be filled in with numbers. Your speed column will be filled in with variables. And your third column will always be distance divided by speed. So the time for the first part of the trip would be 70 over x minus 5. And this would be 60 over x. And I'd better just check something here. Give me a second. I want to check one thing here, that my units are all consistent. That I have kilometers, I'm going to erase it, but I have kilometers for distance, and that means I need kilometers per hour for speed, and it's correct. Okay. So now the key to solving this problem, Sasha, is what do I do with this time of 70 over x minus 5 and this time of 60 over x? If the question, everybody, said it took them the same time to travel the 70 kilometers as it did for them to travel the 60, I would just do that. I don't think it says that. There's a relationship here, and it says that one of the times is 4 hours, 4 days. Is it days? It is. Ooh. 4 days more. Which is 4 days more? This one, right here. This is more time. It's a larger time. Which means if I were to represent, Sasha, 70 over x minus 5 pictorially and compare it to 60 over x pictorially, 70 over x minus 5 is a bigger number. It took more time. So if I were to put an equal sign here, this equation would be weighted down this way, to the left. I need to add that extra time to the smaller time to make these equal. And I need to add 96. Because it's 4 days and my units were in kilometers and kilometers per hour, my time has to be in hours. Man, they even throw that on top of everything, that you got to worry about converting the days to hours. That's the equation that we need to solve. Would you like me to continue? Okay. Is there anybody else who would like me to continue? And I don't mind. So I'm going to do, even though nobody said yes, I'm going to do just a couple of steps here. You would have to multiply everything by x and x minus 5. These would cancel. You would have 70x. These would cancel. You would have 60 times x minus 5. Plus, nothing would cancel here. You'd have 96x times x minus 5. You have to now expand that all out. It's going to be a quadratic formula. You can see you're going to get a 96x squared. So if it's factorable, I don't like that big number of 96. Even if it's factorable, I would use the quadratic formula. But it's entirely up to you how to solve it once you simplify it. Other questions? Go ahead, McKenna. 13? So two water sources working together fill a pool in 2 hours. So here's the pool. And what we're saying is, if you have source 1 and source 2 adding water together, it takes 2 hours. Okay, that's if they both work together. If you only have source 1 working together, and I'm just using 1 for A, 2 for B, it's 3 hours. What if we used only source 2? Question mark. Well, what I've taught you, and really, my advice is you need to remember the shortcut. Because trying to solve this and set this up, like the way your textbook does, I don't know if you want to even look. It's a little scary what your textbook does. It's confusing. So what you do, let's just call this x, is you remember that I've told you that this number has to be equal to the product of these two over the sum of these two. Normally you would know this time, and I would ask you to find this time. I shouldn't say normally. I don't know what's going to be on the exam. Maybe it will be one like this. So, just to take a break and a pause, don't read this question and see two numbers and go, oh, I'm going to go 2 times 3 over 2 plus 3, because it may not be that you're given the 2 to begin with. So now I can multiply both sides of this equation by x plus 3 or 3 plus x, whatever you want to call it, to get rid of that denominator. So what happens, McKenna, is that cancels, and we're left with 3x equals, that cannot be right. This is supposed to be 2, isn't it? The reason I knew I had made a mistake is when I expanded this out with a 3, I'd get 3x, and all my x's would cancel. Okay, so I get equals 6 plus 2x, and I can solve this. I can subtract 2x from both sides and get x equals 6. Is that okay? We can always check this. If this is 6 hours, then the product of these two numbers divided by the sum of these two numbers better give us the 2. And you can check it out at will. Other questions? Go ahead. 14? So this is the upstream, downstream thing. The two distances are different. I just had to read the question. It says they paddle 18 kilometers downstream, so I can put 18 here. They travel 8 kilometers upstream. I can put 8 here. The rate of the current flow is 3. So just a second here. The example we did in class, I gave you the rate at which they could paddle, right? And let's just do this in a general way. When they were going upstream, we took the rate of the paddling and we subtracted the rate of the river. Right? So I don't know. I think it was 6 meters per second they could paddle at. So we had 6 minus x when they were going upstream. Okay. When you're going downstream, the water is helping you out, which means it's going to be the speed that you paddle at plus the speed of the river. And again, I want to make this very clear here. In yesterday's example, we knew this, and we're trying to find the speed of the river. In this question, you know the speed of the current. And we're trying to find the speed that they can paddle at. So, one final thing here. When we did this problem that Sasha asked about, I put x in for the speed that we were trying to find, right? That's what makes this one different. I don't put x in here. This is speed. What I put is x plus 3 and x minus 3. So what I'm saying here, everybody, is that x is the speed of the paddling, which we're trying to find. You might have to use a bit of common sense here, but when I say what is the speed that they would move at in still water, that's the speed that they can paddle at, because the water's not moving. It's not affecting their motion. The time then will be, I really don't like this word rate. I would go with speed. And I don't know if I've been writing S for speed or V for speed. It doesn't matter. Although if you go on and take calculus, we use S for distance, which is a weird thing. Anyway, this time will be distance divided by speed. This time will be distance divided by speed. And the column that I filled in with green here, Ashlyn, is the one that we build the equation with. So numbers, check. Variables, check. Third column, by using the other two columns, done. Now we build the equation. What's the relationship between these two times? Like with the buffalo or whatever it was, the cows, we had to add 4 days somewhere. They're the same. This is a case of them just being equal. We don't have to correct it at all. We're just going to say 18 over x plus 3 is equal to 8 over x minus 3. I hope that everybody recognizes that I've said numerous times, cross multiplication is okay, but it's not the best idea. Cross multiplication will work if it's one fraction equaling another. But if it was that, cross multiplication won't work. So as much as I say cross multiplication is, I don't like it, it has its uses. 18 times x minus 3 will be equal to 8 times x plus 3. I will leave it to you to finish that problem on your own, because it's not even going to be quadratic. It's going to be a linear. I think you're going to have 10x equals 30. Can't be. 18 minus 8 is 10. 54 plus 24, 78. Whatever 78 divided by 10 is, 7.8, I think. Other questions? Okay, I would like to just run through, just to get our brains focused on what it was we did in this unit. Because even though it started off fairly tame and fairly easy for most people, I know from experience that this is one of the harder units in terms of an exam. So I do want to spend a few minutes going through the topic. Simplifying rational expressions. How is it you simplify a rational expression? 2 words: factor, cancel. I mean, I could embellish that and say, well, it's more involved than that. What do I mean when I say factor? I could go through all of the ways to factor. I'm not here to do that. What do I mean by saying cancel? I could say cancel a factor that's on the top and the bottom, right? You can't, I mean, I hope you know this, but if you factor something, sure. If you factor something and you get that, I hope you know when I say cancel that if somebody actually does this on an exam, I totally lose interest in what they're showing me because they don't understand anything about math at this level. That's not what I mean by cancel. I don't lose interest. I'm just saying that that's a big red flag to me that this person doesn't understand anything in this unit. That's not what I mean by cancel. In fact, if you take a look at this factored stuff, can it be simplified at all? No, there's no factor that's common on the top and the bottom. Just to make sure, how many factors are there on the top of this expression? There's just 2, right? They're the things in brackets. How many factors on the bottom? 2. So if you're ever going to cancel something, you have to cancel something that is in its own set of brackets on the top and the bottom. And by the way, I don't mean that if the top was x plus 8 plus 10, that you could cancel the x plus 8s. Because it's got to be in brackets multiplied. So simplifying rational expression, that's what you do. Equivalent rational expressions. Just be aware that if you take a rational expression and you multiply it by 1 to get a new rational expression, that this rational expression and this rational expression are equivalent. We didn't talk about this at the time, but if you take one of the rational expressions that's more complicated and simplify it, you have to get the other one, right? Because if I factor this, I can cancel the a's, and I get the same thing. So there's lots of ways to talk about equivalent rational expressions, but the bottom line is, you know that when you add factors to the top or the bottom, top and the bottom, or you take them away from the top and the bottom, you still have the same expression. It has a different appearance. It has a different mask on. Non-permissible values, well, factors in the denominator. Are not allowed to be 0. Just want to check something. So, what does that mean? It means that if I had something in factored form, that x would not allow to be, in this case, it would not allow to be 5/2 or -2. And I chose that example because even though the x plus 2's cancel, it's still, that non-permissible value survives, okay? There is one other situation here that we need to talk about with non-permissible values, and that's if I have, and I'll just do this by way of an example. This. Are there non-permissible values here? Yep. The non-permissible values can be found by putting 2x minus 5y not equal to 0 and solving this. So that would mean 2x is not equal to 5y, and that means x is not equal to 5/2 y. Okay? So, for example, are we allowed to use y equals 8? How about this question instead? Are we always allowed to use y equals 8? When are we not allowed to use y equals 8? And this is something you would see on the exam in a couple of days. When x is equal to 20. Because if I put 8 in for y and I take 5/2 times 8, I'm going to get 20 for x. So y equals 8 is allowed, yes, as long as x is not equal to 5/2 times 8. As long as x is not equal to 20. Is x ever allowed to be 20? Sure, as long as y is not 8. So there's an infinite number of non-permissible values, but they happen in pairs. For every x coordinate, there's a y coordinate that's not allowed to exist, which means that x coordinate is also not permissible. All right, we're into the middle of the race where we can pick up the speed. Multiplying rational expressions, factor and cancel. Because remember, this rational expression multiplied by this rational expression, I better label these. These two rational expressions being multiplied, and I don't think you need to write this down. I don't know why I didn't use kitten. These two rational expressions being multiplied, whoops, are exactly the same as this single rational expression. And I just told you that when you have a rational expression to simplify, factor cancel. So how do you multiply rational expressions? Factor, cancel. So if this happens to factor into that, and this happens to factor into this, can I cancel the two mice? Yes. Even though one is in the numerator of one expression and the other is in the denominator of the other, it doesn't matter. If it's on the top and on the bottom, it cancels. Done. By the way, you always find your non-permissible values before you cancel. What's the only difference for dividing? Miles. Yeah. You flip any rational expressions you're dividing by. So if I have A over B divided by C over D, how do you solve this? You turn this question into A over B times D over C. And how do you solve that? You turn it into AD over BC, which is a single rational expression, factor and cancel. By the way, you don't actually multiply this stuff out, right? You factor it. You keep making it into more and more factors. By the way, B, D, and C are all non-permissible. So any denominator that you have and the numerator of anything you're dividing by, you have to consider for non-permissible values of the variable. This is where things got more complicated. Okay. Listen very carefully. When you're adding or subtracting, and I know that there are many of you that are sitting there going, I know how to do this, but I know that fewer of you know how to do it than you believe. I know that people get shocked when they write an exam in this unit. They think they had it all and they didn't. It's important for you to understand there is no equal sign here. So I'm going to give you a specific example. Add the following rational expressions. So how would you add these rational expressions? Well, there's no equal sign. It's just a single thing we're trying to put together. You would factor everything completely. And this is a fairly tame one. And you would identify the lowest common denominator, which would be 3 plus x, 3 minus x. I hope you understand that 3 plus x and x plus 3 are the same. Right? Okay. I'm going to go away from this for a second, and if you're writing this down, I'll come back to it. What if I had a rational equation? Let's say that I had 3x over 9 minus x squared plus 2 over x plus 3 equals 12. There's an equal sign. These two things, this thing on the top line that I've written, and this, both involve adding rational expressions, but there's an equal sign here. So you would still factor everything. And you would still say the lowest common denominator is 3 plus x, 3 minus x. And again, I'm not a fan of students figuring out stuff on their own all the time. I think you need somebody to show you how to do stuff. But I think if you can reason it through from time to time, it sticks better. I'm going to put both of these up on the screen. On the right-hand screen, you have solving rational equations, where you have an equation, there's an equal sign. We've factored everything and identified the lowest common denominator. On the left-hand screen, you have adding or subtracting rational expressions. We've factored everything, we've identified the lowest common denominator. Here's my question that I want everybody to think about. We do something with the lowest common denominator when we're adding or subtracting that's different than what we do when we're solving the equation. What's the difference? Because some of you on the exam are going to end up doing to what's on the screen on the left what you should be doing to the screen on the right, and vice versa. What do we do with the common denominator? Let's start with the left screen, which if you're watching this on video is what you can see. What do we do with that common denominator? I got lots of time. I'll wait it out. We found it for some reason. This is what I've tried to teach you, is everything you do in solving a math problem, you do one thing so you can use it to do something different. Miles. Numerator. No. That's, if I understood you correct, is what we want to do here. Sasha.
Do you multiply it by 1 until they all have?
Right. We convert everything that's on the screen right now, we convert to the lowest common denominator so we can bring them together. So what I would do here is say to myself that this already has the denominator, but this one doesn't. It's missing the 3 minus x. So I'm going to multiply the top and the bottom by 3 minus x. And what this accomplishes is then I have the same denominator and I can add them. And Miles, what you were saying was just multiply only the top, and we'll get to that in a second. Okay? So what's the end result here? The end result is that we have 3x over 3 plus x, 3 minus x, plus 2 times 3 minus x over 3 plus x, 3 minus x. I hope everybody is fine with me rewriting the x plus 3 as 3 plus x. Okay. So now we can put them together. We've accomplished our goal. 3x plus 2 times 3 minus x over our common denominator. We're not done, but I want to walk away from this just for a second because the rest of it is not my point. We are adding and subtracting. There's no equal sign. You find a common denominator to get everything with that denominator so that you can combine the terms. All right? What do we do here? Why did we find the common denominator here? Miles. Yeah, we're going to multiply the numerator. Well, we can say numerator, but we're going to multiply this by the 3 plus x and the 3 minus x. This by the 3 plus x and the 3 minus x. And this by the 3 plus x, 3 minus x. What, and the reason why, Miles, I kind of balked or paused at saying we're multiplying the numerator by it, is we don't want to actually multiply it through. Why are we putting those up there on both sides of the equation? What does that accomplish? You get rid of the denominators. So there's a big difference here, right? When you have an equation, your goal is to remove the denominators. And now you have an equation that would be 3x plus 2 times 3 minus x equals 12 times 3 plus x times 3 minus x. And this is an equation where I've used this description before. Everything's on the working line. I don't have any exponents. I don't have any denominators. I haven't got anything weird going on. I just multiply it all out and solve the equation. Going back to this one, we would have to multiply this 2 through and write 3x plus 6 minus 2x over 3 plus x, 3 minus x. And then we can write it, this will be our final answer, as x plus 6 over 3 plus x, 3 minus x. We're done. We've simplified it. We're not finding x. There was no equation to solve. Here, I don't know that I want to solve this equation because I think it's going to be quadratic, and you know how to do that, but we'll see. This is 3x plus 6 minus 2x. Don't read too much into why that happens to be what we had in the corresponding question where we were adding things in the numerator. Equals, and I hope you guys can see this is 9 minus x squared. So if I multiply that by the 12, 12 times 9, 108. Twelve times 9 is 108. And then we have 12 times negative x squared is negative 12x squared. So you would have to solve this quadratic equation, 12x squared. I guess we have plus x on the left, and then we have 6 minus 108, which is minus 102. I would be blown away if that's factorable, just because I chose numbers at random. So you'd probably have to solve this using the quadratic formula. But we might as well do a b squared minus 4ac thing. B squared, that would be 1 squared minus 4 times 12 times negative 106. I don't think so. No. Is it 102? Oh, it is. Thank you. Why did I have 106? Don't know. I doubt it. No. But thank you. Yes, you're right. So you would have to solve that using the quadratic formula. This is where, I mean, things are peaking in the unit. Factor, cancel, flip, factor, cancel. Pretty basic stuff. Adding, subtracting was where we ramped it up a bit, and then solving equations was where we ramped it up a bit more, and that leads us to word problems, which I don't have anything to say formally about this other than you need to know how to solve word problems. And that means come up with the equation on your own so that you can find a common denominator to multiply everything by it to get rid of it and solve the equation. So I have a handout I'm going to give you here which has multiple choice and numerical response questions. I see that it's not 3-hole punched, so I'm just going to take a minute and give this to you, and that's what we're working on today and tomorrow, with your exam being Friday. Man, it's Wednesday already. I love these short weeks. Hopefully that's enough. So again, you know the drill. Tomorrow I'll talk about the structure of the exam in a little more detail. You bet.